Hey all, welcome back. As some of you may know, I got an xTool D1 laser previously, which had been great to use during my PC builds. However, the exposed laser produced a lot of smoke when cutting and engraving wood. As my workspace is on an apartment balcony, I did not like the idea of the smoke bothering my neighbors. As such, we will be building a stand and enclosure for this laser today. This will be a quick and simple version to get me started as I needed to use the laser immediately for my projects. I started off by cutting pine legs to the same length as my existing workbench. Then a sheet of 9mm MDF was cut for the worktop. Each of the 4 legs will be screwed into the top using just one screw. Pilot holes were drilled into the ends of the legs to prevent cracking of the wood. As you can see, this structure is hardly stable enough for our purposes. This is where 3mm MDF panels are cut up to reinforce the stand. The thin MDF panels were attached to the legs using a staple gun. Just look at the difference the panels have made to the stability of the stand. With that sorted, I then installed 2 beams near the bottom of the legs which will be used as a support shelf. The basic structure of the stand is now complete. xTool is actually having a massive sale at the moment for their 3rd anniversary. If you're looking to get a laser for yourself, check the links in the description below for a great offer. Now let's move on to the enclosure. First, we make 2 side frames using 40 by 19mm pine. A notch the same size of the connecting piece is cut out to provide a more stable joint. Here's a tip. When you don't want to measure the drill holes accurately when joining 2 pieces of wood, first drill the hole for the screw at roughly where you want it, then insert the screw, position the pieces together, and hammer the screw gently so it leaves a mark on the mating piece. Then a pilot hole can be drilled in this location and they will connect nicely. While the frames are drying, I cut 3mm melamine coated MDF for the panels for the enclosure. These panels are also attached to the side frame using a stapler gun. In this view, you can have an idea of the workspace I use for my projects. It's not very large, but we have to make do with what we have. A cross brace was then added to the enclosure to allow mounting of the hinged top panel. A window was cut from the top panel to be able to monitor the laser during operation. As the top panel is only 3mm thick, I used some scrap MDF to act as a mounting plate when screwing in the hinge. To cover the window, I had clear plastic sheets that came off a cheap picture frame I bought previously. I cut these to size and attached them to the panel using double-sided tape. Now, on to the fume extraction. Most enclosures I've seen on sale have the exhaust port sticking out the side. This is fine functionally, but I wanted something that looks more elegant while taking up less space. What I came up with is creating a baffle within the back of the enclosure. Scrap pieces of 6mm plywood was glued together to form this baffle. This is then glued and screwed onto the back of the enclosure. Since most fume filters have a rounded duct, I needed a way to adapt the rectangular baffle opening to a round opening. This was achieved by making a manifold. The laser would have been perfect to cut this circle in the plywood, but this is the classic case of needing the thing you're building for the build, if that made any sense. Anyways, the rest of the enclosure was glued up and M3 mounting holes were tapped around the circular opening. To allow the air in the enclosure to flow downwards, a slot was cut into the stand surface that is the same size and position as the internal baffle. The manifold can then be attached to both the back panel and top surface of the stand. This should give a better idea of how the airflow will travel. A 3D printed adapter was made to connect the filter duct to the manifold. I also needed a place to put the air assist pump for the laser. Instead of making a separate shelf for it, I decided to just attach a scrap piece of plywood onto the top of the filter box, which would act as a shelf. Then a bracket was printed to attach the flow control under the stand surface. Another cable clip was added to tidy up this space. A power board with individual switches is then attached to the side of the leg. This way, all the equipment can then be powered using just one socket and be switched on and off independently. The filter duct can now be connected. Some white duct tape was applied to the corners to hide the staples. A strip of tape was also placed on the back of the enclosure to seal up a small gap between the enclosure and stand. This is to ensure the filter is sucking most of its air from inside the enclosure. The tape seals the gap when the stand is pushed up against the wall during usage. The stand and enclosure is now complete. Don't forget to check out the links in the description for some awesome deals xTool is currently having for their products. You might have noticed that there is no ventilation holes in this enclosure. Instead of cutting out ventilation holes for this enclosure, I decided to just cut the panels so that there is a 20mm gap around the bottom sides of the intake. This simplifies the manufacturing process while still providing adequate airflow. As you can see, the extraction system works well at removing the smoke. While it does not completely remove the smell, it has reduced it significantly to a point where I am comfortable running it on my balcony. That's pretty much it for this video. As I use the laser more, I will identify improvements which can then be implemented in a version 2. Thanks for watching and I'll see you in the next one.